One tool that we have to discover where the possible roots are at in the entire realm of all numbers is something called the rational zero theorem. And basically what it says is that if we're looking for some possible rational zeros, if there are rational zeros, we're going to be able to narrow the search down by looking at the difference or the ratio of the factors of the constant term over the factors of the leading coefficient. So let me give you an example of what we mean by this, and I hope as we do you can appreciate when we're having to deal with something how much easier the search becomes. So let's look at polynomial function f of x equals now remember, we don't have a quadratic formula to find the roots of this one. That's for second degree. Our friend Tartaglia had a formula for third degree roots. But after that, boy, there's really not a general formula, but there's only methods, and this is one particular method. So what does this method say to find possible rational roots? Is we want to look at the factors of the constant term. That's the constant term. And we want to look at the factors of the leading coefficient, which is a -1. And we want to look at the ratio. So what are all the factors of the constant term? Well, there's a 4. 4 is a factor of 4. So it's -4. Plus or minus 2 are factors of 4. And plus or minus 1 is a factor of 4. All the factors of the leading coefficient. Leading coefficient is a -1. So what's a factor of -1? Plus or minus 1. I want to really appreciate how cool this is. We found if there is a rational zero, a solution to this equation right here, one of these combinations is going to be one of those solutions. And so what does this look like? Again, we talked about the ratio of all the factors of the constant terms all over the factors of the leading coefficient. So that produces plus or 4, every combination here, which leaves me with plus or minus 4, plus or minus 2, and plus or minus 1. I only have to look at 6 possibilities. Did you get that? I only have to look at 6 possibilities. And I think as we continue to progress and practice, you're going to appreciate that so much more. 6? We only have to look at 6 in this particular case. That's awesome.